A wind farm is not just a collection of turbines. It's a complex dynamic system that constantly interacts with its environment. Every wind turbine, every component, is subject to the unpredictable forces of nature. The efficiency and longevity of these infrastructures depend critically on how we manage this interaction. The ability to anticipate wind behavior is critical to the operational and economic optimization of a wind farm. It's not just about generating energy, but doing so in the most efficient, safe, and cost-effective way possible. Accurate prediction enables proactive rather than reactive management. To address this critical need, we introduce the Environment and Prediction Agent. This intelligent system represents a significant advance in wind farm management, transforming uncertainty into a strategic advantage. Its function is to provide the farm with an early view of weather conditions. Wind is the essence of wind energy, but also its greatest source of uncertainty. Its volatile nature, with intermittent changes in direction and speed, presents constant challenges for wind farm operations. This inherent variability requires sophisticated management. Unexpected changes in wind direction or speed can have severe consequences. They can lead to underproduction, trigger unnecessary alarms, or, in the worst cases, cause significant structural damage to wind turbines. Lack of foresight directly impacts profitability and safety. The lack of advanced forecasting generates multiple operational and economic problems. Shutdowns due to unanticipated extreme winds are common, as are overloads from unforeseen gusts that stress components. Production is suboptimal due to the lack of precise turbine reorientation. Furthermore, maintenance is scheduled inefficiently, as good weather windows are not identified in advance. The inability to operate accurately in the electricity market is another disadvantage, resulting in penalties or lost revenue. Reactive management limits the wind farm's potential. The primary function of the Environment and Prediction Agent is to act as an automated industrial meteorologist for the wind farm. This system goes beyond simple data collection, interpreting it to generate actionable intelligence. Its goal is to provide a deep and anticipatory understanding of the environment. The agent's process is comprehensive and multifaceted. It collects real-time data from various sources, integrates high-resolution global weather models, and, from this information, generates highly accurate local forecasts. This data fusion is key to its accuracy. The Environment and Prediction Agent performs three key interconnected functions. First, it fuses environmental data, both local and external, to build a complete picture of the environment. Second, it predicts short and medium-term wind behavior with high reliability. Finally, its third crucial function is to detect adverse conditions early enough to enable a proactive response. These three capabilities work together to optimize operations and protect the wind farm's assets. The primary objective of the Environmental Data Fusion Subagent is to collect, compare, and merge quality data from multiple sources. This integration ensures a robust and redundant view of the environment. The reliability of predictions directly depends on the quality and diversity of the input data. This subagent integrates data from various critical sources. It uses the turbine's own sensors, such as anemometers and wind vanes, to obtain direct and localized measurements. It also incorporates information from the wind farm's own meteorological stations, which provide additional reference data. Crucially, the system is fed by globally benchmarked numerical weather prediction (WP) models. These models provide a solid foundation for larger-scale predictions. Furthermore, information is cross-referenced between nearby turbines, detecting patterns and anomalies. A practical example of how this works is the detection of an imminent change in wind direction. The subagent merges the data from the wind vanes of several turbines, compares it with the NWP model predictions, and adjusts the internal model for a coordinated overall rotation of the wind farm. This enables early and efficient reorientation. The objective of the short and medium-range forecasting subagent is to anticipate future wind behavior as accurately as possible. It uses advanced artificial intelligence techniques to process the merged data and generate detailed forecasts. This predictive capability is the heart of the system. The subagent operates on two distinct prediction horizons, each with a specific purpose. The short-term horizon ranges from minutes to 3 hours, allowing for real-time micro-adaptations of the turbines. This is crucial for reacting to gusts or sudden changes. The medium-term horizon extends from 3 to 48 hours, facilitating more strategic operational and market decisions. It allows for production planning, maintenance scheduling, and optimization of electricity market participation. Cutting-edge technologies are used to achieve these predictions. Machine learning models are trained with large volumes of historical data from the fleet, learning complex patterns and nonlinear relationships. Recurrent neural networks, such as LSTMs, are particularly effective for time series. Hybrid models are also used, combining different approaches to maximize accuracy. A key component is self-learning, where the system automatically adjusts its models based on past deviations between predictions and actual observations. This ensures continuous improvement. A practical example of its application is predicting an imminent drop in wind speed. The system can then recommend reducing turbine load to avoid unnecessary stress or schedule a maintenance window just before production drops significantly. The primary objective of the Adverse Condition Detection Subagent is to protect wind farm assets. It identifies extreme or hazardous weather situations that could compromise the safety or performance of the turbines. Its function is to prevent damage and optimize protection. This subagent is designed to detect a variety of critical conditions. It identifies the formation of ice on the blades, a phenomenon that drastically reduces efficiency and can cause imbalances. It also alerts to approaching thunderstorms, which pose a risk to the infrastructure. It detects extreme winds or gusts that exceed the turbine's safe operating limits. Severe turbulence, including wake turbulence generated by other turbines, is also monitored to prevent excessive loads. Finally, it can identify dense fog that impedes maintenance operations. A practical example of its usefulness is the early detection of icing on blades. The subagent automatically activates blade preheating systems before the buildup becomes significant. This prevents production loss and the risk of damage due to imbalance. The Environment and Prediction Agent does not operate in isolation. It is an integral component of an intelligence ecosystem. It collaborates in real time with other agents in the wind farm system, sharing critical information and receiving feedback. This interconnection is vital for holistic management. The relationship with other agents is fundamental to the farm's operation. The farm orchestrator agent receives predictions from the environment agent to adjust the overall production strategy. This enables more efficient generation planning adapted to future conditions. The wind turbine control agent receives detailed instructions from the environment agent. These instructions include adjustments to the yaw, nacelle orientation, pitch, blade angle, and rotation speed. This optimizes energy capture and reduces mechanical stress. The maintenance agent greatly benefits from these predictions. They receive suggestions on optimal windows for interventions, taking advantage of periods of low wind or stable conditions. They can also receive alerts to cancel scheduled maintenance if bad weather is forecast. Finally, the electricity market agent uses the environment agent's predictions to report on expected energy supply. This allows the park to optimize its market share, avoiding penalties for deviations and maximizing revenue from energy sales. An illustrative case study is the ability to avoid shutdowns due to unforeseen gusts. The environment agent predicts an erratic wind gust in advance. The orchestrator agent receives this information and automatically reduces the pitch angle of the affected turbine blades. This preventive action prevents an emergency shutdown of the turbines, resulting in significant cost savings and continued production. Anticipation of the gust allows for a smooth and controlled response, protecting assets and maintaining generation. Another success story is early ice detection to maintain performance. The environment agent detects conditions conducive to blade ice formation. It automatically activates preheating systems before ice accumulates. This prevents the loss of production that would occur if ice formed and affected the blade's aerodynamics. This proactive action ensures that the turbines operate at maximum efficiency, even in winter conditions. A third example is adjusting the electricity market strategy based on expected wind conditions. The environment agent predicts a significant drop in wind speed for the next few hours. This information is communicated to the electricity market agent. The market agent adjusts the power supply to the electricity pool, thus avoiding penalties for not meeting the energy commitments. This supply optimization translates directly into a tangible economic benefit for the wind farm. The implementation of the environment and prediction agent has demonstrated quantifiable benefits in real-world wind farms. A significant 42% reduction in unexpected alarms has been observed. This indicates more stable and predictable operations, minimizing disruptions. The accuracy of electricity market offerings has improved by 18%. This greater accuracy in production forecasts enables more efficient and profitable participation in energy markets, reducing penalties for deviations. In terms of the structural health of wind turbines, a 23% reduction in accumulated fatigue loads has been achieved. The ability to anticipate and mitigate extreme wind or turbulence events extends the lifespan of key components. Finally, the accuracy of maintenance window scheduling has increased by 33%. This allows interventions to be carried out at the most opportune times, minimizing downtime and optimizing wind farm availability. The environment and prediction agent represents a fundamental evolution in wind farm management. It transforms the uncertainty inherent in wind power into a competitive strategic advantage. By providing the farm with forward-looking information, production is optimized, infrastructure is protected, and profitability is maximized. This intelligent system is a cornerstone of predictive and efficient wind energy operations. Its ability to merge data, predict the future, and detect risks early makes it an indispensable component for the wind farms of the future. Investment in this technology translates into tangible and sustainable benefits. In our next video, we'll delve into another vital component of wind farm intelligence, the data and communications broker. We'll explore how information flows through the system, from sensors to the cloud, and how the security of this critical data is ensured.